Hello guys, welcome back to John's Workshop, and in this video we're going to be making on a theme of the Joe Piezinski tap wrenches. So anyone who watches Joe's channel may have seen him make some simple to make tap wrenches, but very nice looking and very effective. And I'm making these two reasons. One, my tap wrenches I've got are rubbish, they're all import, cheap, nasty, horrible things. And secondly, because I've made my tap follower now, that if you've seen that in my last video, I need some different style tap wrenches that will actually hold on the shank of the taps as opposed to on the square of the tap at the top. So that's what these will do. So I'm just going to bring you in at the board now and we'll have a look at it in a bit closer detail. I've done something a bit different, just really as just an example of a different way that you can dimension something up when you're making similar to components but multiples of, if that makes sense. So we'll come in at the board and I'm not going to go through it in too much detail, but just give you a quick show of how I've pulled the dimensions together, how I've designed it roughly, and then we'll crack on with the manufacture. Okay guys, we're at the board. So Joe Pie tap wrench with maths, and that's not a picture of Joe Pie, just in case anyone thought it might be. That's a picture of a guy with slightly more hair than me who's looking very unhappy because he's got maths to do. Don't worry, I'm not going to go into too much detail with the maths. What I thought I'd show here, I want to make two tap wrenches that look something like this, and I thought, how can I draw both of those up? They're very similar in feature wise. The features are the same, the sizes are going to change. So I thought, let me use a style that's often used in industry, again just trying to let you benefit from my experience of various different industries I've been in, where you've got lots of dimensions like we've got here, that where the geometry is the same but part to part the dimensions change, and they'll basically use sometimes called parametric dimensioning. That's more in the CAD space, but it's tabular dimensioning in the 2D sort of pencil drawing space, if you want to call it that. So basically what I've done is drawn out what I want. I've labelled the dimensions, or given them a parameter. So diameters, A, B, C, D and E, lengths Z, Y, X and so on, and we've got a thread T1, we've got an angle which is AN1. So you can see what I've done there. I'm just using different letters to mark out and identify the different features. And then what we've done is drawn a table and started populating what we want for each of the tap wrenches. I'm going to make two, a small one and a large one. They're both going to come out of, if you look at diameter E, which is the major diameter, the biggest diameter, they're all coming out of 16mm diameter 304 or 304 stainless steel. So that dimension E is the same on both, and then obviously we've got different dimensions going through here. And I thought the only thing possibly to point out, that probably just another way of dimensioning things that you may come across and you may see. So when you're doing stuff like this, you can then refer to your names, and that's what I've done here. So to calculate angle AM1, which is this angle here, what I've done is I've drawn it's a right angle triangle. Basically, if I draw this triangle that this describes, this shape, it's this triangle here. It's a right angle triangle. Tangent of the angle AN1 is equal to the opposite over the adjacent, and all I've done to create the adjacent is I've made this side delta 1, this side delta 2, and delta 1 is equal to L2 divided by 2, which is LZ, which is the overall length divided by 2, so that basically cuts the part in half, minus Ly divided by 2, and Ly is the centre spigot, so basically half of that centre spigot. So you take that away from half the overall length, and then minus Lx, which is this parallel section here, and that leaves you with this straight section. And then similarly for the adjacent side, which is this the opposite side, which is this small area here, that's diameter E, which is our major diameter, minus diameter D, which I've drawn in cutaway section up here, which is the minor diameter, divided by 2, and that will give us that length there. So just a different way of dimensioning things up, and a different way of using labels, if we want to call them that, or parameters, to dimension something up in a tabular form like this. And it's the reason I did this was A, to try and just show people who might not have come across this before, a different way of doing things, and B, I didn't have enough room on the whiteboard to draw this thing out twice and dimension it all twice, and it's much quicker once you've drawn it out once to do it this way, because you just plug in the numbers into the table. So I thought that was worth showing if you might be doing something similar. And sometimes, you know, for two different variants, there's not a lot of benefit. But in industry, and I'm going back to aerospace, you could have 25 different variants of the same thing. So this way then becomes really effective, because you just create a big table with all the values in it. So without any more babbling or any more maths, apart from to say, for those of you that have stickers in your channel, obviously the more stickers you send me, the less room there is for maths. So think about that. So without further ado, we will get onto the lathe, and we will start with the first one of these two. And I'm not sure whether we do, I think we'll do the small one first. So I'll join you in a minute at the lathe. Right guys, we're just setting up for the small tap wrench. I'll just make sure our jaws are clean. So this is 304 stainless, and I know that I need 57. Yep, that'll do, that's near enough. What we're going to do is just turn one end. We're going to face off, turn one end with the taper, drill, tap, clearance drill and counterbore, and then we'll turn it, we'll probably then cut it off, part it off, whatever, and then turn it round and machine the second side holding on the first side. I think we'll give that a bit of thought. So I've got a tool with a nice big corner radius on it that we're going to use for the angled section, so that we leave a nice big corner radius in the smallest diameter, so it's nice and strong. I've just put a mark on with a Sharpie of how far I'm going to go in, and I'm just going to make a mark with the tool at that point on OD for a start, so I've got a guide to work to. So there's our mark. We'll lock the carriage off now. Got my compound slide in the right place. I've set my compound over at 8 degrees, which is the angle for this particular one. And we'll start cutting and see what happens. So there we go, that's our first angle done. I'm just going to get a chamfer tool now and chamfer those edges. Right guys, so we've had tapping drill down 5mm for M6 and I've gone past centre, and I've now got the clearance drill on M6, so 6.5 drill. I've got myself a Sharpie marker on the drill, how deep I need to go to leave myself enough depth for the thread. So I'm leaving myself about 13, 14, 15mm of thread at the end. So we'll just put this one down now. So just a tip, when you're machining stainless like this, any work hardening material, if you're doing what I've just done there and you're only taking a small amount out each side, so I've gone from 5mm diameter to 6.5, which is 3/4 of a mil a side, 1/30 a side, you don't hang about with it. Get the drill in and just feed it hard, because if you start hanging about with it, it will start to work harden and the drill will just get really grotty very quickly and your surface will get work hardened and it will just look a right mess in there. You probably heard a bit of the noise when the drill first went in because I wasn't going fast enough and hard enough, and I just fed harder and that noise disappeared. So you really need to feed this stuff hard, and the same's true for turning as well. Don't mess around with this stuff. You need to be cutting it, because if you're not, you'll have all sorts of problems. So I'm not going to deburr that yet. I need to bore that out now for the cap head, but I'm going to do the tapping first, I think. So we'll get the M6 tap and we'll put the M6 tap in. So I'm not brave enough to try and power tap this. My M6 taps aren't the best. So I'm going to try and start it manually, and we'll see what it feels like. So I'm just applying a bit of tailstock pressure. We'll call that far enough without any feel. That's what's bottomed out there now. So we might have to put a, that was a second tap I think, we might have to put a plug down. We'll see what our depth of thread is once we've drilled the cross hole, but I have gone plenty past centre, so that we should be enough there I think. So next job is to get the counter bore for the screw head. Okay guys, we've just turned that round in the chuck, so we're going to face up this end, measure, finish the overall length. I can just get the verniers in, measure up to the shoulder, and then we'll turn the taper on the second side. Alright then guys, we've got both of these made. The small one you saw me make, the big one we've made to the same standard, and that's been drilled and tapped for an M8. So next job now, on the small one at least, we're going to thin this central band out. Not the best setup in the world. I think we're just below centre, gripping in the vise, so I'm going to be taking this really steady. Right guys, we've just flipped that the other way up. We've sat it on something that's vaguely parallel, so that I know we're not too bad this way, and sort of front to back I've lined up the flat that I've already milled on it. So we're just going to mill the same flat on this side now. Alright guys, there we go. That's got both of those complete. As complete as they're going to be. So you can see there, 2 tap wrenches with the cap screw sitting in one end of it, and if you look in the middle, hopefully this is going to show up, but the other end of the thread has been chamfered. I'm trying to see in the camera whether you can see that or not. Yeah, hopefully that's showing. So we've got a chamfer on the end of the thread there, 45 degrees, just hang ground on, just to stop if that mushrooms with gripping taps, you know, you can still get the screw out. So that's the small one, and then there's the large one. For the large one I didn't need to reduce this diameter, so we've just left it as stock with the hole through the middle. Same deal, cap screw in the end and chamfered on the end of the, why can't I get that in shot? There we go, on the end of the clamping screw. So we've got a chamfer on the end of the cap head. So I'll just zoom out a little bit, and I'm just going to answer a question that's been raised in one of my previous videos. I'm working quite ahead of time here, so I've only just released my workshop tips number 2 video, and there's been some questions around the, I'll just bring it into shot, excuse my fingers. There's been some questions around the tap follower. I don't know if you've seen that video yet, but that's the tap follower that I made. There's been some questions around how is the cone end of the tap follower going to work. So I'll just zoom out and show you that this was all part of a bigger plan for these things to work in conjunction with each other. So I'll bring you back in a moment and just demonstrate that. Right then guys, we've got an M, we've gone for the small end because this is obviously the length of the square on the small end of tap is the shortest, and also the smaller the square is, the further up inside this cone it's going to travel. And some of the questions have been asked around, based on that, would you still be able to get a tap wrench on what's left of the square that you can actually see once you're using this sort of cone end adapter. And I knew that was going to be the case, and basically I didn't let that steer the design because I knew I had these tap wrenches in the back pocket, and I'd seen Joe Pyszczynski show these tap wrenches, and basically he had exactly the same issue with his tap follower, which is different design to mine. But I'll just use this small one. So this is an M3, I think that's an M3 tap. So we'll just load that up into the small tap wrench. And basically what Joe shows in his is you don't actually grip on the square, you grip on the diameter portion of the shank. And what that allows, there's two reasons, there's twofold for that. The first one is it allows you to grip with some intelligence. So if you've got a really tricky hole that you're tapping in some nasty horrible sort of mnemonic or something like that, the tap will spin in the tap wrench before the tap breaks in the part, so you can adjust the tension that you're applying. Whereas if you're driving on the square, you don't get that ability to do that. Secondly, what he said is, and he's absolutely right, if you need a bit more drive, and that's probably going to be more so with the bigger taps, you can just grind a small flat on the shank of the tap, and your cap screw bites up against that small flat that you've ground on. And I like both of those ideas. And his tap wrench, as I said, these are an out and out copy really of his design on the tap wrench. Slightly different. And that's the reason I milled this flat on the smaller one, was to not obliterate too much of that tap shank on the small taps. And as you can see there now, if I demonstrate, if I use my tap follower with the cone end on it and I bring that into engage on here, you can see that I could actually move that tap wrench up by 1/4 of an inch there. There's enough clearance, so I could move that slightly further up the tap, but that will work perfectly fine, and it will hold the back of that tap in place. So hopefully that's answered a couple of the questions. And as I said, it was part of the design. I always knew that I was going to be making these tap wrenches to go to work in tandem with this tap follower. So I'll just finish this video up now, and I'll bring it back and we'll just wrap it up. So there we go, guys, that's the end of the small tap wrench build. Hope you found that interesting, and I hope, like me, some of you may have seen that design. You might not have seen Joe's video, but I've just basically copied his ideas there because I saw it and I just thought that's a really, really good design. I think he made his out of stainless as well, so I've even copied the material choice, only really largely because I've got some stainless in the right size. So I'm really pleased with those. I think those two tap wrenches in conjunction with my tap follower are going to prove incredibly useful in the workshop, both on the lathe, on the mill and on the bench. So what I'll do, probably just to close this out, I'll just kind of step to one side so you can see that. You can freeze frame or whatever it is, you can have a look at those dimensions and you can make these yourself following the video along should you wish to. So as I said, I hope you found that useful, and thank you to my subscribers, thank you to my new subscribers. I had quite a few just come in just today, and that's largely due to a shout out that I've had from Aid of Aid's Workshop on his channel. So thank you, Aid, I appreciate that. We're just about to crest the 900 subs mark, so we're getting ever closer to the magic 1,000 number. So again, I don't sort of like begging for subscribers, that's not what this is about, but if you do watch and you do enjoy what you see and you're not yet subscribed, please consider clicking the subscribe button and clicking the like button, because it just helps me grow the channel. And just a final thought on that, I've had an email from YouTube, so I'm not monetized, I've not set up any kind of monetization or anything like that, and I'd never really intended to, but what some of you guys may be seeing from at any point, I think they said from the start of June roughly, is YouTube are going to start putting adverts on people's channels even if they've not got an account with them and they're not monetized. So, you know, apologies guys if adverts do crop up on the channel. That's not through my choice, that's through YouTube's choice, and they will be doing that. I don't know whether they'll do it at the front, at the back, in the middle, really don't know. I know it can be disruptive. Please, if you do get that, let me know so that I'm at least aware that it's happening, because obviously I can't see it from my end, so that will be useful feedback for me. Okay, we'll call it at that. So thank you all for watching, and we'll catch you all very soon when we'll be making something else.